Hello everyone, welcome to my YouTube channel Chemistry Lovers. Today I'm gonna show you some uh, important information about the coordination or complex compound that you should know. The uh, complex compounds are generally perform inner or outer orbital complex. So how can I determine or say that whether this complex ion is inner or outer orbital complex? So there is a process through which we can determine the inner or outer orbital complex of a complex compound. So first of all, we have to find out the coordination number of this respective ion, where more than one same or different type of ligands can form coordinate bond with the central metal ion. That's the special characteristics of the complex ion or complex compound. So in this video I am showing you some examples through which you can easily calculate or determine the inner or outer orbital complex of some chemical compounds. So let's see how if you are not able to see the board clearly, then you can ask me through the comment section. I will try to solve it. Okay. So first I am taking this complex compound. Okay, here it is. I hope you are able to see the board clearly. So here the first example I have taken. Here it's a complex compound where the 4 chlorine atoms are connected with the central metal ion nickel through the coordinate bond. So now we have to determine at first the coordination number through which we can say it either inner or outer orbital complex. And another important information regarding this concept, you have also know the strength of ligands, that is the strong field ligands or weak field ligands, because due to the strong field ligands the 3d or 4d orbitals of the central metal ion is splits into two parts, that is T2g and Eg, from which the electrons are separated, and there is a probability of for pairing of electron from unpaired electron, that is the unpaired electron gets converted into paired electron due to the influence of strong field ligand. Okay, so these some key concepts you should kept in your mind while you are solving this type of question. So the first coordination number, I have to find out first coordination number. What is coordination number? Coordination number is in short the valency, not primary one, secondary valency of the central metal ion, that is the ligands which are connected with the central metal ion and forming this type of complex compound. This is the coordination number, which is 4, because 4 chlorine atoms are joined with this central metal ion nickel through coordinate bond formation. And you can also determine the oxidation number of the central metal ion by assuming that x minus 4 equal to minus 2, that is 2 Ni2 plus, that is nickel 2 plus. So first, now we have to calculate that it is either inner or outer, that is if it is sp3 or dsp2, that I am gonna show you. Nickel electronic configuration I have written argon. So here it is nickel, the electronic configuration of nickel argon 3d8 4s2 4p0, because atomic number of nickel is 28 you should know this. So I'm writing the electronic configuration in this way, where the valence shell is 3d8 4s2. So I am now writing the orbital structure. Okay, 3D. There are 8 electrons present in 3D orbital of nickel. So first I am writing here 8 electrons. D subshell contain 5 orbitals. Sorry for the background noise. Okay. Um, there are 8 electrons present in 3D orbital. There are 5 first unpaired electron, and second this here it is 4s2, that is 2 electrons, and this 4p0. So there are no electrons present in the 4p. Only 3d and 4s are involved in this. Now Ni2 plus, after losing 2 electron, the configuration is this. There is not much enough space present in this board, so I am writing here. If you are not able to understand properly, then I will try better next time. So 2 electrons are removed from this 4s subshell, not from this, because the energy level, there is a little energy difference present between 3d and 4s. So the 2 electrons gets removed from this, not from this. So 4 is 0, and there as it is same. Now the question arises that if this 2 unpaired electron gets paired or not, because I have talked earlier that there is a probability for pairing electrons from unpaired to paired. So there are 2 unpaired electrons present here. So if it is paired or unpaired, so the answer of this question is depends on the strength of ligands. I have already told you that the strength of ligands, weak field and strong field ligands, 2 type of ligands present here, and chlorine is a weak field ligand. So this 2 unpaired electron does not converted or gets pairing, because chlorine is not a strong field ligand, chlorine is weak field ligand. So these 2 unpaired electrons present in the 3d orbital as well, just as this previous one, and these are 4 empty orbitals present in the Ni2 plus, and these 4 orbitals take part in the hybridization, that is sp3, and from this we can say that it is an outer orbital complex. Here the outer refers that the pairing does not occur. Pairing of electron does not occur in this case, so we have to say that it is outer. So I hope I am explaining you. I am able to explain you the whole incident, what is going on actually, and why I am considered it as outer orbital complex, not inner. So if you have any questions or doubts regarding this theory, then you can ask me through the comment section. Okay, now another example I've taken, which is belong to the outer orbital complex, not inner. This is the last example through which you can be able to solve this type of question. While solving this type of problems, you should keep in your mind about the strength of ligand, because you have to know the ligands which are strong and the ligands which are weak, because due to this you can easily solve this type of problem. Okay. This I have taken also another example for you in order to understand clearly what I am actually saying or trying to show you. So this is also a coordination number I have to find out, because due to this we can easily solve that whether it is inner or outer orbital complex. Okay, coordination number is 6 because there are 6 ligands, that is cyanide, for attached with the central metal ion chromium. So there are 6. Now whether it is inner or outer orbital complex. Now so we have to at first look out the electronic configuration of chromium, which is argon 3d54s1. 24 is the atomic number of chromium. You should know this. So 3d54s1, 4p0, and 4d0 also. I hope you guys have written this. So I have to remove the earlier portion because there is not much space present in this board. Okay, please consider. This is 3D, which 5 electron present here, all are unpaired. You can look, and 4s1, 4p0, but there are no electron present here. Now after losing 3 electron, because this is chromium 3 plus, oxidation number of chromium in this compound is plus 3. So 3, after losing 3 electron, from which orbital the electron gets removed? This is the question and very important thing in this whole theory. Here the 4s subshell contain one unpaired electron. So first the electron removed from this subshell, 4s subshell, and the another 2 electron gets removed from 3d. So I'm gonna show you again. 3d, 5 minus 2, that is 3, 4s0, 4b0, 4d0. 1 electron from this and 2 electron from this, the total 3. 3 electron present. Okay, here no electron is present, and if this 3 electron gets paired or not, this is the very important question which I'm show you. That's these 3 electrons cannot get paired with each other because there are no electron present in the other orbital. As you can see, these are all vacant. The electron removed from the 4s is 1 and the other 2 is from 3d. So total 3 electrons gets removed, and there are no electron present which are exist as pair. So these 3 electron cannot get paired with each other. These are exist in this form, that is unpaired. So it is either inner or outer. What do you think? This is an inner orbital complex because here 2 orbital becomes vacant. D2sp3, I think. 2, 3, 4, 5, 6. Yes, D2sp3, that is here it is. Here the D2 means 2 orbital from 3d, 1 from 4s and 3 from 4p. These 6 vacant orbital take part in hybridization, where these ligands, that is cyanide, can form coordinate bond with them. So it is D2sp3. By the previous one I have taken, which is sp3, but this is D2sp3. sp3 d2 is different and d2sp3 is different. These are not same, but though their hybridization or coordination number is 6, but their uh, structure is different and the electronic configuration is also different. So I hope you guys can be able to understand the entire concept. If you have any doubts regarding this, you can please ask me through the comment section. I will definitely try to sort out your doubts. Okay, and if you like my video, then please share, like, subscribe my channel Chemistry Lovers. In this channel mainly I am bringing the concepts, some chemical reaction mechanisms regarding chemistry subject. So if you are interested towards this subject, then you can ask me several theories or questions which I have tried to bring the video. Okay, so up to this, thank you.